Good afternoon, class. Today we're looking at lines in more depth. I know we graphed lines in the last assignment, but here we're taking more of an algebraic approach to lines. And I think I need to,
When you say algebraic, you mean as opposed to geometric?
yes, as opposed to geometric. So let me see. Here we go. We said the last time that standard form for the equation of a line is ax plus by equals c. We can be more specific now. If your equation contains both x and y, then you're looking at a slanted line. If there's an x and a y in the equation, you're looking at a slanted line. There are two other types of lines that are not what I would call slanted. The first one is a vertical line. And remember, by vertical, I mean up and down. It's running up and down. A vertical line, you can spot that equation very quickly because the only variable it has is the x variable. The equation will be in the form x equals a number. Now to graph a vertical line, you have to make sure that it's solved for x because that thing there says you're crossing the x-axis at the number n. So I'll write that out. X equals n is a vertical line passing through the number n for number, on the x-axis. For example, suppose you wanted to graph the line x equals 3. You see that it has an x and no y, so you have a vertical line passing through the x-axis at the number 3. There's the number 3 on the x-axis. Draw yourself a vertical line.
If you're wondering how do you graph a slanted line, well, they did that the last time.
Yeah, that's what we did the last time.
And you're
Remember,
gonna
we
do
plugged
one
in
in a
0
moment.
for x and found y, plugged in 0 for y and found x. I think I'll number this. There are 3 types of lines: slanted lines, vertical lines. What's the third type of line? Horizontal line, I agree.
Mm-hmm.
A horizontal line has to have an equation of the form y equals a number. Oh, and I should remind you that horizontal lines run left, right.
Not up, down.
Not up and down. Vertical lines run up and down. Remember, a student once had a way of remembering that, the difference between horizontal and vertical. And I said, oh, do you want to tell the class? And she told the class. It was very vulgar. And so I'm not asking for y'all for ideas on how to remember the difference between a vertical and a horizontal line. I learned my mistake there. But the equation has to be in the form y equals a number.
It involves this first syllable.
No, yeah.
And
Tell me.
yeah.
Okay. So a horizontal line. Now I can't say the word horizontal without thinking of that first syllable of what. Okay.
Now rewrite this sentence, replacing the word, the
yes.
letter x with y.
You have to make sure the line is solved, the equation is solved for y. In that event, it's a horizontal line passing through the number in on the y-axis. That tells you what axis it's passing through. It's passing through the number n on the y-axis. So something like y equals 3. If you wanted to draw the graph, we're just freehanding. So you go to the number 3 on the y-axis. Here's a way you can remember when you're drawing the graphs. Here's a non-vulgar way to remember this thing. You go to the y-axis to the number 3. If you freehand your graphs the way I do, you make that little horizontal tick marks there, you extend the mark. You don't have a vertical mark there at 3. You have a little horizontal mark. You just extend the mark. And there's one other thing I want to remind you of that we mentioned the last time involving lines. How do we graph these the slanted lines? We would find the intercepts. Remember I said that an x-intercept, is there room down there? I'll go up a little bit more. X-intercept. That's the point on the x-axis where the graph passes through it. And I'll say point on x-axis. And if it's on the x-axis, you can go left, right, but you can't go up or down, which means that to find an x-intercept, you have to let y equal 0. And we had ordered pairs that look like this. You'd have a number there for x, but the y value would be 0. And
You've got to write it down here. Don't flip to another page.
I'm not going to. Y-intercept. That's the point that you're looking for on the y-axis. And if the point is on the y-axis, like this ordered pair right here, you don't go left, right, which means the x value is 0, the y value is 3. So to find a y-intercept, you let x equal 0, or you complete an ordered pair where x is 0 and you find y.
So if you wanted to say something mathematically, suppose someone sees you and says, oh, you and Mr. Precella, say something mathematically that you learned today. You can say vertical lines have x-intercepts. Vertical lines do not have y-intercepts. The vertical line can't pass through the y-axis. Similarly, down here, what would you say about horizontal lines have?
What type of intercept? X or
Y?
A y-intercept.
Horizontal lines don't have x-intercepts. They don't cross the x-axis.
While we're thinking about this, let's think about these. Give me some points. Look back at this graph right here. That's the point, what? 3, 1. And this one right here, what would be the coordinates of that second point I just labeled? 3, 2. What about this point right here? Assuming integer values, what would that be? 3, -2? Do y'all see something? All these ordered pairs have something in common. Every point on this vertical line has an x value of 3. Notice every point on that vertical line, the x coordinate is 3. That's why x equals 3 is a vertical line passing through 3. It contains all of the ordered pairs whose x coordinates are 3. Apply that same logic to horizontal lines. Give me the coordinates of this point right there, assuming that they're integers. -2, the x value is -2. What's the y value? 3, okay. We already said that this point right here is 0, 3. What about this point here? 1, 2, 3, 4. We go to the right 4, but what's the y value? Every point on this green line has a y value of 3. That's why y equals 3 describes this horizontal line. It's saying draw the line that has every point whose y values are equal to 3.
Now, don't get confused. The y-axis is vertical.
But y equals that line is horizontal.
So it might be exactly the opposite of what you think. So you've got to think of it. It's crossing this axis.
At that number. It's passing through the x-axis at that number. Y equals. Yeah, you're right. The y-axis is the vertical axis, but y equals 3. That's telling you which axis it passes through and at which number. It passes through the y-axis at the number 3.
Maybe we better start.
We better do some examples before we get timed out. 2.
Oh, I assume that means we're doing problem.
Yes. Okay. Find the intercepts and then graph the line. This is number 2. Let me write down the line. The equation is x minus 3y equals 6. And they want us to find the intercepts and then draw the line. Well, once we find the intercepts, we'll probably be able to pick out the correct graph just by looking at the intercepts we're finding. I'm going to make a table of values just like we did on Wednesday. First thing we do is plug in 0 for x, and then we're going to plug, oh, wait a minute, there. And then we're going to plug in 0 for y. Let's start off with plugging in 0 for x. We're plugging in 0 for x. That says 0 minus 3y is equal to 6. Well, 0 minus 3y is a negative 3y. What does that tell us about 6? About y. Divide by negative 3 to get y equals negative 2. So I just now found out where the graph is going to pass through the y-axis. It'll pass through the y-axis at negative 2. Now let's find out where it's going to pass through the x-axis. We're plugging in 0 for y. So we have x minus, what's 3 times 0? We can do that in our head. 0. So we have x minus 0 equals 6. X minus 0 is just equal to x. So x equals 6. So where the number is located, that's telling you what intercept you're looking at. We first of all found the y-intercept, and then we found the x-intercept. It's passing through the y-axis at negative 2. It's passing through the x-axis at 6. We may be able to just tell, because you have to write out the intercepts. We may be able to just look at it and pick it based on the intercepts. Let's look and see. We graphed these things the last time. 0, negative 2, and 6, 0.
A, B, C, or T. Let's see.
Not A. It can't be A. No, wait. I'm just looking at the intercepts. Look, they have a negative 6, 0. So that's wrong. It's not A. What about B?
It's B.
I think it's B. Let's look at C. 0, negative, no, they have a 0, positive 2. And D, the same thing. There's only one option that has these two ordered pairs, 0, -2, and 6, 0. Response B.
Let's look at the graph.
It's passing through the y-axis at -2. Is that -2?
Is this -2 right here?
Notice they're incrementing in units of what? 2.
Two.
They're incrementing in units of 2. You're right. So that's -2 on the y-axis. What about the x-axis? Does it pass through 6?
Is this 6?
Is that 6 where Tony's pointing? Yes, it is. 2, 4, 6. So it must be response B.
Okay.
Number 3. Oh. Why did I need to make up those special cases a moment ago? Okay, look at that. They want us to graph. I made up x equals 3. Oh, I made up x equals 3 here. But what are they giving us for number 2? What's the problem they're giving us? X equals 2. Is it going to be vertical or horizontal? We can analyze the graph and pick out the response, I think, without showing any work. Will it be vertical or horizontal?
Passing through the x-axis.
So is it vertical or horizontal? Vertical. It's going to be vertical, so we can discard A.
It can't be A. That would be y equals -2, right?
Right.
Okay.
It can't be C. So it's either B or D. Which one?
This would be y equals +2. Which one is it?
B.
B?
I agree. It's passing through the x-axis at 2. Okay. So
the work is up here, not on the paper for that problem.
Number 4.
Any questions on that? How we got that answer B without, if you're sitting there thinking it looks like he did nothing, well, it's up here. Okay.
Graph the line y plus 2 equals 0. Okay, let's switch over. So I see that we have a y and no x. That means it's going to be a horizontal line, but where is it going to pass through the y-axis? Before we draw the graph, we have to do something. What do we need to do? Okay, we got to get that y by itself. So I'm going to subtract 2 to give me y equals here. -2. So that's saying it's going to pass through the y-axis at -2. Okay, passing through the y-axis, we go to -2, and we extend that little horizontal mark there.
Are you caught up with us? Any questions?
A, B, C, or D.
Okay, so it's a horizontal line passing through -2. Okay. Oh boy, that would annoy me if I'd been a student out there. That's about saying the same thing at the same time.
A and B definitely not, because those are vertical. So it's either C or D.
C. X. So see, these first two pass through the X. Which one did you say it is?
C.
D?
C.
Oh, C? Okay, I'm deaf. Oh, there it is. Yeah.
So select C.
Okay.
And I need to write some now, so
Let's flip it over here.
Okay, the slope measures the steepness of a line. The slope is a measure of the steepness. How steep is the line? Is it real steep? Is it almost flat? Another way of thinking of the slope of a line is it tells you how much how the y value changes when you increase x by 1. I think I'm going to write that down. The slope tells you how the y value changes when you increase x by 1 unit. Well, if you're looking at a slanted line, there are two possibilities. Either it can be rising from left to right, or it can be falling from left to right. It can be, there are two special cases, a vertical line and a horizontal line. There are the four possibilities when you're looking at lines. Now, we use the variable m to denote slope because people say, oh, because the slope measures, the m comes from measure. No, they started using this m like money, to denote the slope when Keyes, it was an economist that discovered something called margins. It turned out it wasn't anything new. Mathematically, it was the slope and derivative of, so it wasn't anything new, but he gave it the initial m. So the mathematical community, tolerated that and continued using that lowercase m to represent slope. If a line is rising from left to right, you expect the slope to be positive. As you move to the right on x, if it's rising, you expect the y value to keep going up. So if it's rising from left to right, the slope is positive. When you're looking at a line falling from left to right, the slope is negative. As your x value increases, your y value is going down. So when a line is rising from left to right, we expect a positive slope. When your line is falling from left to right, we expect a negative slope. I think we'll look at a horizontal situation first, okay? Let's look at a horizontal. Oh, I have a horizontal line drawn right here. Let's think about what happens on this horizontal line. Here's one point on the line, and here's the other point. I'm moving from 0 to 1 on the x-axis. My x value is increasing by 1. How is the y value changing from this point to this point? How does the y value change? Does it change? We increased x from 1. X went from 0 to 1. How did the y values change? They didn't. A horizontal line has a slope of 0. You can change those x values all you want, but the y value is never going to change. In order to be a horizontal line, all those y values have to be the same. Now, let's apply a logic like that to this vertical line. Let's look over here at a vertical line. Here's a vertical line. We want to know, if I were to increase x by 1, what happens to y? On a vertical line, can I increase x by 1? Do I have any points on this vertical line whose x coordinate is 4? No. To ask, how does y change when x changes is meaningless. On a vertical line, x can never change. It's always the same. So we say that for a vertical line, it's meaningless to talk about the slope. The slope is undefined.
We've seen that word undefined.
I was just thinking of that. We've seen that word undefined. We've talked about it in terms of fractions. When is a fraction undefined?
0 on the bottom.
Zero on the bottom, that's right. A number over 0. That'll be important, okay? And,
I'm going to do rise over 1 there.
yeah, okay. So everyone through, I'm about to flip the page. Geometrically, we have this intuitive notion. We know that the slope tells us how the line is slanted or the amount of steepness, but geometrically, we can say that the slope of a line, denoted with the lowercase letter m like money,
That's a cursive M
That's
because
a-
it has too many humps, doesn't it?
1, 2, 3. I don't want it to be confused with n. If you see this little thing with three humps, that's a m for slope. Geometrically, we can say that slope is equal to the change in y over the change in x. And that change in y geometrically is referred to as the rise of the line. The change in x values is referred to as the horizontal run. So you'll hear people saying slope is equal to rise over run. Well,
We better do number 5 before we get timed out.
yeah, let's do that. To illustrate what I mean by rise over run. Let me see. This is number 5.
Let me try to
I'm gonna draw this picture, okay? So where are the intercepts? I don't need it to be real, my picture, I don't need it to be real exact, but I do need to draw it to have something to point at as I'm discussing this. So you may just want to not bother drawing this graph, just watch what we're about to do.
It looks like it's passing through the y-axis for you.
1, 2, 3. Is that 4? Does that look like 4 to y'all?
Right here?
Yeah, looks like it's passing through the y-axis at 4. And where is it passing through the x-axis? 1. So if we draw the line connecting those dots, there.
I'm here breaking my own rule. I didn't even read the instructions.
Oh,
I
wait
just
a minute.
assumed it said
Find the slope of the line.
Okay.
Yes, okay. So switch to my
Wait,
paper.
look at part B. The slope is undefined.
Wait a minute. Could it possibly be that? What sort of a line has an undefined slope? Vertical? Verticals are undefined. Goodness. Verticals have undefined slope. Is number 5 a vertical line? No, so it's not going to be that. What about 0? Could it be? Could the slope equal 0? What sort of a line has a slope of 0? Horizontal line. Is number 5 a horizontal line? No, so it's a, hey, look at this. It's falling from left to right, so we know something. Will the slope be positive or negative?
Negative.
Negative. When x is increasing, y is decreasing. Well, what I do is I determine the slope using rise. If I'm given a graph, and I have to be able to clearly see 2 distinct points, and I have. To use rise over run, I start at the bottom and point and work my way to the top point. What I do is I usually start at the bottom and I work my way to the upper point. So starting here, the rise, I have to go 1, 2, 3, 4 units up. So I'm going to say the rise is positive 4. That means I'm going up 4 units. And I'm situated now at that X right there, where I put that little X. Now I need to actually get to this point. I'm going to move horizontally. I'm going to move to the left how many units to get to this second point? I'm going to go to the left 1 unit. Movement to the left is considered to be negative. So we have a run of -1. In general, movement up is a positive rise. If I had gone down, it would be a negative rise. Movement to the left is a negative run. Movement to the right is a positive run. +4 divided by -1 gives me a slope of -4.
And that was going from from bottom to top.
If you want to go top to bottom, you'll still get the same slope. If you started here, say you're going to start at this top point and work your way to the bottom point. If you start here, what's your rise going to be? Is it going to be positive or negative? Negative, we're going down. 1, 2, 3, 4. We move down 4 units to get on the same level as that secondary point. So the rise is -4, but what's the run? We're positioned here at the origin. We need to move to that second point. We're going to go, will we go in the positive direction or the negative direction? Positive direction, 1 unit. -4 divided by +1, we still get the same slope of -4. So it doesn't matter which point you start at. I generally start at the bottom point and work my way to the top point if it's a slanted line.
Up is positive, down is negative, right is positive, left is negative.
Any questions there?
Oh, let me punch in the answer. -4.
I'm going to make up a couple of examples.
Oh, okay.
Okay. Yeah.
Let me go back over here.
Find the slope. I think what I have here is just too jammed up, okay? So I don't like the way I have it jammed there in a little corner, those 2 special cases. So here's my first line.
X-axis and Y-axis.
Yeah, my x-axis and my y-axis. I have a vertical, I better put on the little tick marks, otherwise it's hard to tell which line is the axis and which one is the line that we're trying to find the slope of there. So let's suppose we have the vertical line passing through 2. I'm going to say find the slope and equation. I'm making up this problem so I can change the instructions if I want to. Something I can't do with my lab, but I want to find 2 things. I want to find the slope of this line and the equation. The equation, okay, it's vertical. What letter appears in the equation of a vertical line? I'll give you a hint. It's either X or Y. A vertical line, what letter appears in its equation? It's passing through the x-axis. So x equals, where does it pass through the x-axis? 2. So there's the equation. Now, let's try to, what have we already said over here in this little corner? I said the slope would be what? If it's a vertical line, the slope would be meaningless. It's undefined, right? Well, let's justify that. Let's say here and there. I'm going to use rise over run. I'm going to move from this bottom point to the top point using rise over run. We start here. What will my rise be to get to the second point?
About 1.5.
No, it's an integer.
Oh.
That's not 1.5, it's an integer. So what would y'all use as an integer? It doesn't really matter whether you use 1 or 2. I'll say what I wanted to show was a rise of +1. And then I'd be positioned at this point. What's my run? How many units left, right do I have to move to get to this second point? 0. 1 over 0. We just now justified why the slope of a line is undefined. If you use rise over run, we're going to have a formula for slope in a moment. If you use the formula for the slope, if it's a vertical line, you're going to get a denominator of 0, which is undefined. Any questions on our logic there? So we just justified why the slope of any vertical line is undefined. Let's do part B. Does it take a genius to figure out what sort of a line I'm about to draw? What's the other special case? You have vertical lines and you also have horizontal lines. So let's see. Suppose I have this horizontal line right here.
Passing through 2 on the y-axis.
What would be the equation? Since it's horizontal, what's the equation? Y equals 2. Okay, there's the equation. Passes through the y-axis at the number 2. Now what about the slope? I'll label 2 points on the graph, there and there. I could use any 2 points. I'm going to use these 2 points. Let's use rise over run. Well, I'll just start at the point on the left since there's not one above the other one. I'll start right here. What's my vertical movement to get on the same level as this secondary point? How many units up or down do I need to move to be on the same level as that point there?
Up to?
0. I'm not going to move up or down. So the rise is 0.
You're going from this point to this.
You can't go up or down. So the rise is 0. What's the run though? You're trying to go from this point to the secondary point.
0.
No.
3.
The rise is 0. The run, 1, 2, 3.
So
Any future teachers here in this class? Here's a teaching tip, okay? Someone that never answers the question wrong. Always has the right answer. When he finally answers and says something wrong, the teacher pounces to draw attention to it, okay? He finally said...
And that's a
bad teacher trait, okay?
Tip,
But, okay.
Let's see, since there seemed to be a little bit of uncertainty, let's just talk your way through. If you were telling someone how to move from this point to this one, you would say move up 0 and right 3. Up 0.
So the rise is 0.
Right
and then we
3.
move to the right 3.
Or you could
Although
say
it doesn't
down
really
0.
matter. 0 divided by any non-zero number is 0. Okay.
Good.
Oh, goodness. We just now went through and justified why all horizontal lines have a slope of 0 and why all vertical lines don't even have a slope. To talk about the slope of a vertical line is meaningless. Because if you try to find it, you're going to get a denominator of 0. And we know fractions with a denominator of 0 are undefined. Okay? But as I said, we wanted to take an algebra. Here, all of this is geometric. We need an algebraic approach to slope of a line. Suppose we don't want to plot those points every time we're trying to find the slope of a line. Given 2 ordered pairs, and I'll just use x1, y1.
Like the last time.
And x2, y2, we were using these points the last time with the distance and midpoint formulas. The slope of the line
And this is a formula now.
It's a fraction. To get the rise, the vertical movement. Which one of these coordinates gives you vertical movement? X's or Y's? Oh, I forgot my equals. There. Which coordinate gives you vertical movement, X or Y? Vertical movement, moving up and down. Y gives you the movement. Now, when a line is going up and down as an equation with an X, but the vertical movement is measured in terms of the Y values. So to get that rise, you're starting at the second point, you're trying to get there, subtract the Y coordinates, Y2 minus Y1. That gives you the rise of the line. And then the horizontal movement is measured in terms of X values. So X2 minus X1 gives you the run. Use this formula when you're trying to find, when you know two ordered pairs and you're trying to find the slope without having to graph the thing and count. So number 6. This is a pretty painless formula compared to, say, the distance formula the last time.
Y minus first Y over second X minus first X.
We want to find the slope of the line, and it's important looking at those directions. If you don't have the directions there, well, what do they want you to do? Do they want you to find maybe the distance from one point to the other? Do they want you to find the midpoint of the segment connecting those two? Here they want the slope. The slope of the line passing through 1, 4 and 2, 7.
If you just mentally thought about those 2 points, if you plotted them up here and connected, it's not a vertical line. So it's certainly not undefined.
It's not horizontal either. If it's a horizontal line, the Y values have to be the same. So it's a slanted line. Let's use our formula. Just like I did with distance and midpoint, the first point I write down, I'll think of as X1, Y1. The second point I wrote down, I'll think of as X2, Y2. So here we go. M equals. It's the second Y, so 7, minus the first Y, 4, all over the second X, 2, minus the first X, 1. Well, this is a pretty nice one to start off with because there are no negative coordinates. 7 minus 4 is 3. What's the run going to be?
1.
1, 3 over 1. So our slope is a positive 3. So knowing that that thing's positive, that means it's rising from left to right. The fact that it's 3, for every increase in X, Y value goes up by 3, it'd be pretty steep. It looks something like that. It'd be a pretty steep slanted line.
And if I can
But all they're asking for is the slope.
I remember years ago a student said, well, why do we really need this when we could just plot the points and count? And I said, yes, but imagine if this 7 were a 700.
Heck, a 17.
17. Counting? Okay, I got to go from 700 to 4. You don't want to count that many.
Suppose it's a 700.3.
Oh.
You sure wouldn't want to count.
Okay.
How would you count that? That's what this formula's doing. It's saying subtract the Y's to get that vertical movement, subtract the X's to give the horizontal movement. Type in the answer 3, Tony. Let's do number 8.
Oh, heck. Here's a darn. Oh, here's another one.
Okay. I looked earlier and it looks like number 8 has at least one negative coordinate there. So that's what I
think I made it
wanted.
too big.
Find the slope of the line, and 0, 2. The line is containing or passing through negative 8, 5, and 0, 2. Negative 8, 5,
Left 8, up 5.
and 0, 2. It's going to be falling again. So it's going to be another negative slope, but that's fine. Identify x1, y1, and x2, y2. I'll write the formula down. But once again, those coordinates, negative 8, 5, wouldn't be hard to plot. 0, 2 is easy to plot, and it'd be easy to count those, okay? But suppose you had numbers that were not easy to count. There. I'm going to let y'all tell me what's going to go where. What am I going to write here?
2 minus 5.
2, okay. And here you said I'd write 5. So y2 minus y1. Now x2, 0 here.
Negative 8.
Watch out for those double negatives. You have a 2 minus 5. That's a negative 3 all over. What are we going to get for the denominator?
8.
Remember, the double negatives become a positive. So 0 plus 8. There's our slope, negative 3/8. To me, anything, a slope bigger than 1, that's pretty steep, okay? We had a slope of 3. That's why I said it was a steep line. This thing here, negative 3/8, 3/8 is less than 1. It's negative, so if you plotted the points, it'd be falling, but it wouldn't be that steep. It wouldn't be that steep. It'd be something like that. But once again, they're not asking you to analyze the graph. All they want is the slope, negative 3/8.
Ready for me to type it in?
Mm-hmm.
Negative 3/8. Any questions? Okay.
Okay. Now we're going to write, as I said, we're taking more of an algebraic approach to lines here, even though I keep going back to geometric interpretations. Oh, it's falling from left to right because it's negative. We're still trying. This section is more algebraic than the last one, and we know standard form for the equation of a line is ax plus by equals c. Suppose you took standard form and you solved it for y. You moved the x term to the left and you divided by the coefficient of y. That is called, I'm going to draw a line here to separate because we're starting something different. That is called slope-intercept form of a line. Slope dash intercept form of a line. The equation, when you solve for y, will look like this. Y equals mx plus b. If you solve the equation for y, that number in front of x is going to wind up being the slope. And that will always happen. If you solve for y, the coefficient of x is the slope. That's why I use that m there. And this number here is going to tell you where the graph passes through the y-axis. Where graph passes through the y-axis. And I know that's not how you spell through, so I'm just trying to be short. The point where the graph passes through the y-axis, we have a terminology for that. the point on the y-axis, what do you call that? Starts with an I. The
Y.
the y-intercept. So we can say that the y-intercept, remember, we're defining intercepts in this course as ordered pairs because that's how this textbook does it. So it's passing through the y-axis at B. There's my grid. Don't write this down. And there's the number B. How do you denote that as an ordered pair? Because they're going to want you to label those y-intercepts as an ordered pair. What's the x value for a point on the y-axis? How many units left-right do we go? 0. Remember I said for y-intercept, every x value is 0, and the y value is b. So when they want you to write out the y-intercept, you'll have to write it as an ordered pair, 0, comma b. This number here will be the y coordinate of the y-intercept. And that shows you how things change. Textbook authors do, over time, actually manage to change mathematical definitions. When I was in school, when Tony was in school, intercepts were just numbers. The y-intercept would have just been b. I remember in the mid to late 80s when textbooks started defining them as ordered pairs. And I remember a colleague, a graduate professor at SFA, choosing a college algebra book, and she was like, oh no, we will not use this book because they define intercepts. They don't know what intercepts are. They define them as ordered pairs. Well, she's retired now, and so it's a good thing because all the books define it like that. And I'm rambling. Let's go on.
9.
Number 9.
Oh, let me pull it up.
Okay, oh, this is a good one. A good starter problem. Number 9, they want you to find the slope and the y-intercept of the line. The line is y equals negative 5, 6x plus 6. We want to find the slope and the y-intercept of the line. When I look at this equation, it's already solved for y. If it's solved for y, then the coefficient of x has to be the slope. So the slope, when I look there, I know the slope is going to be negative 5, 6. What about the y-intercept? Don't just say 6. You've got to write it as an ordered pair. So the y-intercept how are we going to write that point on the y-axis as an ordered pair?
0 and then 6.
Okay, the x value is 0. That number there tells you where it's passing through the y-axis. So the y-intercept is the ordered pair 0, 6. And it'd be awful if on the first test you miss this answer because when they ask for the y-intercept, the common mistake, people just write a 6. And it's counted wrong.
Instructions will say write it as an ordered pair. But first, negative.
The slope is negative 5 over 6.
Oops. I put over 9. Okay. Check it. Now here's the tricky part. Look at this one.
Oh.
The first one helps you out.
Oh, I was about to say, I didn't know they did that. Look at that. They're making it easy for you, but this is the first one using the slope-intercept form. I bet you it's not going to stay like that. What's he going to type there? The 6. Did you notice they already had the parentheses and the 0 comma? All you had to do was fill in that 6 right there.
Mm-hmm.
I don't think it's going to stay like that, though. Number 10.
10?
Yeah, 10 is fast.
Okay.
Y'all can call this out to me.
2/5.
2/5 is the slope. Good. So the slope is 2/5, the number in front of x. What's the y-intercept? Okay, that's why I wanted to do this one. I knew they didn't keep the 0 comma for us.
The incorrect answer would be just to type a 2.
And here, if you did this in the homework, they'd say, oh, you got to write it as an ordered pair. I can assure you they don't do that when you're taking the test. So you have to know. But notice, they do tell you in the instructions right there.
Type an ordered
Type
pair.
an ordered pair. Type an ordered pair. So they're trying to warn you. So you put the parentheses and then 0 comma
Oops, comma,
comma 2.
2, close parentheses.
Any questions there?
Number 11. Oh, we did. Oh wait, we didn't do 10 because
We did number
we
10.
did 10.
We
but
just
didn't write
talked
it.
our way through it.
Uh-oh.
Uh-oh. Look at this one. Why am I saying uh-oh? Find the slope and the y-intercept of the line whose equation is negative 5x plus y is equal to negative 5. Why did I say uh-oh? If you have an equation containing x and y, you know it's a slanted line because it has x and y. If you want to find the slope and the y-intercept, you can't just look at the coefficient of x first. The equation has to be solved for y. Well, this is painless enough. What can we do to solve this equation so we have y by itself on one side? Add the 5x to give us y equals, put the x term first, positive 5x, and then the minus 5. So what's the slope? The slope is just 5. It's just the number. That's another common mistake. People put 5x. No, it's just the number in front of x. The slope is 5. The y-intercept, you have to write it as an ordered pair. What number goes first? 0. And then where does it pass through the y-axis? At negative 5. That number there is the y-coordinate of the y-intercept.
So it's that classic problem-solving approach. You took number 11 and made it look like number 9. Get that y by itself. So let me punch in that. The slope is 5. Oh, 5.
And the y-intercept, once again, they say type an ordered pair, but they're not giving you the parentheses 0 comma. You have to know points on the y-axis have an x-coordinate of 0.
If you don't put the parentheses, wrong.
Mm-hmm.
Okay.
Oh, they do say
They do tell you,
but
yeah,
not on a test.
not on a test.
They're just going to mark it wrong.
Parentheses there and there. Okay.
Number 12. Find the same instructions. Find the slope and the y-intercept. Let me ask you something. Are we going to have to move terms around the way we did on number 11? Or is this like number 9 where we can just say the slope is 25? We're going to have to move terms around. We need to get y by itself. Switch to the paper. We need to get y by itself. There's really only one sensible first step. What are we going to have to do? Subtract 25x. I agree. So we'll have 5y equals, when we move that 25x over by subtracting, it becomes a negative 25x plus 10. And it's a plus 10 because that's an assumed positive there. We still need to get y by itself. What have we got there that we don't want? A 5, divide through by 5. Divide each term by 5. Realize each term has to be divided by 5. So the 5's cancel, leaving us y equals here. What will that reduce to?
Negative 5x
Negative 5x, I agree, plus here 2. Any questions on our logic there? Because once you get it here, then it's back like number 9. Any questions on our logic up to this point? What's the slope?
negative 5.
Okay, it's just the negative 5. Don't put the x. It's just that number, negative 5. What's the y-intercept?
0, 2.
I couldn't hear you.
Oh, I did. I could hear, but
Oh, I
go
didn't
ahead and
hear
say
you.
it louder.
0, 2.
0, 2. I agree. 0 because it's on the y-axis. You can't move left or right. And this number here is the y-coordinate of the y-intercept.
So negative 5 and 0, 2. Let me remember. Negative 5 and 0, 2. Okay.
Looking at number 13, let me look at that for a moment. I want to make up another one before that. Switch it
Can I
back.
mention something? In math class, algebra especially, you do it one way, then you go in reverse. Starting with number 13,
We're going to be going in reverse.
find the equation. They're giving you the slope. You've got to find the equation. Now, what's this example you've made up? Okay.
Find the equation of the line with slope equal to 4 and y-intercept.
Oh,
Well, it's trying to step them up to this next one. 0, 3. It's trying to
Exactly
get
what I
y'all
was
ready
saying.
for what? It's trying to get you ready for 13, 14, and 15.
Algebra, you always do it one way, then go in reverse. So this example he made up, it's like number 12, going backwards.
Number 12, they had an equation, and we determined the slope and the y-intercept. Now, they've given us the slope and the y-intercept. They want us to go back to the equation. Well, y equals, we know the slope is 4, so we have a 4x. What's my b value going to be? Okay, it's a positive 3, so a plus 3.
It's sort of the reverse of this number 11 here. Just looking at this part that I'm circling.
It is the reverse of it. Here, you had the equation, find the slope and the y-intercept. Here, they gave you the slope and the y-intercept, and you had to go back to the equation. Any questions on our logic there? As long as they give you the slope and the y-intercept, it's easy to write an equation, agree? Okay. Suppose they give you the slope and another point that isn't the y-intercept.
Instead of 0, 3, what if it were 1, 3?
We know y-intercept has to start with a 0. Suppose I just said 1, 3 instead of 0, 3. So as they just said slope of 4 passing through the point 1, 3. Let's look at number 13.
Oh, number 13.
Find an equation for the line of the line with the slope equal to 2, passing through 3, 2. Is 3, 2? Is 3, 2 the y-intercept? No, it isn't. We have a big problem. We already know the slope, at least. The slope, I'm going to have to distinguish between these twos. So the M slope is the one that I haven't, well, it doesn't look like
Pretend it's
red.
red.
Yeah, hold on. There. The slope is the red 2. So we know, using slope-intercept form, we know that we have y equals the red 2 times x. Do we know b? Say no, we don't know b. That's the problem. They didn't give us the b value.
How do you know it's not the b value?
But that isn't 0. That number there isn't 0. That x-coordinate has to be 0 if it's a y-intercept. They didn't give us the y-intercept, but you know what they did give us? They gave us an x and a y. They gave us an x and a y. Well, we could plug in y and x and solve for b. Let's do that. We're going to replace the y with 2, with the black 2. Y is being replaced with that number there. 2 equals 2 times, what's the x value they gave us? 3. So we have 2 equals, 2 times 3 is 6 plus b. Now we can find b. What do we have to do to get b by itself? Subtract the 6 minus 6 to give us a b value of -4. So that b there, instead of y equals 2x plus b, the equation should be, we're going to replace that plus b with the -4. So the equation we're looking for is y equals 2x minus 4. Where does the graph pass through the y-axis? At what number?
That's the slope.
The slope is 2. Where does the graph pass through the y-axis? At what number? You don't have to give it as an ordered pair. -4. This -4 tells you where the graph passes through the y-axis.
So look at that. Wow, we are sort of going backwards. We now have the equation. Y equals, and I can't remember what that equation was.
2x minus 4.
Minus 4.
Any questions there?
This is the strategy that says find an equation.
You know the general form, y equals mx plus b, and they gave us the slope, so we knew one of the unknowns, the m value. We had to find the b value. Well, how do we find the b value? They gave us an x and a y to plug in. There's something called the point slope form of a line. It's one of those great hoaxes perpetuated on the mathematical community. You don't need a point. If you view an example, I bet you they're going to use the point slope formula for finding the equation of a line.
Y minus y1
Equals n times x minus x1. You don't need a separate formula. You can write any slanted line, you can find the equation of using slope-intercept form. Why have a separate formula to have to hassle with? When I'm writing equations of lines, if they're slanted lines, I only use slope-intercept form.
And this is one of those things, at the time when we were in high school algebra, I had no idea I'd ever be teaching algebra or anything, but we had different teachers. And I remember you were doing it like this, just y equals mx plus b. Now, meanwhile, my teacher gave us all the formulas. Y minus y1 equals y2 minus y1 over x2 minus x1 times x minus x1. That's the formula we would have used for number 15.
That 2-point form
Yes.
for the equation of a line.
Why? It was torture. You don't need all those formulas. Y equals mx plus b. Let's do number 14. Oh.
Okay, the same instructions. Find the equation of the line. We want the equation of the
You know
line.
what? I wonder if we could regenerate it and not have the one.
Yeah,
here.
try just
Don't
say-
write those down. Let me see. What would happen if I say saw? Okay,
Oh, this
that's
is
a
better.
better example. Good examples don't have the same number occur in a lot of places. So this might be the best example we've done today.
Mhm. So this line has a slope of 3/4, and it's passing through the ordered pair 7, -8.
That is not the y-intercept.
7, -8. If you think about plotting that in your mind, you should see it's not on the y-axis. They didn't give you the y-intercept. Well, we know y equals mx plus b.
What's the next thing he's going to do? What will he write next?
It's going to plug it in.
I'm
Plug
gonna,
in.
okay, so I'm gonna replace the m with 3/4
If you're
times
wondering, what if they
x
don't give us m?
plus b.
I'll answer that in a moment. They didn't give us b, but they gave us x, y.
I don't want to have to plug in a 7 here
Oh.
and then multiply that
I just
by
noticed there's a
3/4.
fraction.
Oh,
But
okay.
have they learned something about getting rid of fractions?
Yeah, I think we have. We've learned how to get rid of fractions from equations.
What do I need to multiply straight through by to cancel out that denominator?
What would I have to multiply through by to cancel? I'd have to multiply the left side and distribute it over the right side, but it'd get rid of that 4 for the what we're about to do. What would be the least common denominator here? Remember I said if there's only one denominator in the problem, that must be the least common denominator. With that in mind, what am I multiplying by? We have y equals 3/4 x. I'm going to spread it out the way we would do. What am I going to multiply by?
That'll get this 4 to cancel.
If there's only one denominator, and there is, that number has to be the least common denominator. So we're going to have to multiply by 4. How many times do I have to multiply by 4? How many terms do I have? How many terms do I have on the left? 1. How many on the right? So I'm going to multiply by 4 3 times. 1. I'm going to write that as a 4 over 1. 2, 3. But keep in mind, our final answer is going to be in this form here. Y equals 3/4 x plus b. We're just trying to find b at this point. So we have 4y is equal to what's about to happen here. So the 4's cancel out. 3 divided by 1, that's just a 3x plus 4b. I think this equation will be easier to substitute into. I got rid of the fractions just to make the substitution part easier. We're going to have to plug in 7 for x. What are we going to plug in for y? -8. So we have 4. Replace the y with -8 equals, replace the x with 7 plus 4b. The only reason we did this multiplication 3 by 4 was just so that we're just working with integer arithmetic rather than fraction arithmetic.
Can y'all imagine if we hadn't gotten rid of the 4,
we'd have a 7 here. 3/4 times 7, that's 21/4. We have a -8 over here. We'd get that as -8.
Right.
We need to write it as over 4, so -32 over 4
You're getting a common denominator, so you can
minus 21/4. You see, so this is saving us quite a bit in terms of the multiplication and addition involving
Right.
fractions. What have we got here? -32, okay, equals here
21.
21 plus 4b. I'm trying to get b by itself.
Subtract 21.
Subtract 21, I
Yeah,
agree.
That's right.
So we have 4b on the right side, -32 minus 21, that gives me a -53. And then there's only one step left to get b by itself. Divide by 4 to give us b equals -53/4. If you're real good at multiplying and adding and subtracting fractions, then just plug in the 7 here and the -8 there. Without being immodest, I'm very good at it, okay? But I find that students of algebra have better luck plugging in if they eliminate the fractions first. So my final answer, instead of a plus b, what am I going to have there? In place of the plus b, what am I going to have? Okay, I'm going to have that minus 53 over 4.
Write it.
Okay, I'm going to write it right here. The final answer, y
Wait, and
equals,
the final answer is an equation y equals. Okay?
so you have 3/4 times x, and we're replacing that plus b with a minus 53/4. Not all equations are have nice integer coefficients and constants.
But once you multiply 3 by that 4, I mean,
It's not that bad.
so 3/4 x, let me type that in.
Y equals 3/4 x minus 53/4.
3/4x.
No, the
I
x.
know.
Look,
Minus-
notice he put that x in the denominator.
53 over 4.
Well, maybe
Let's
they'll
see.
count it right. What do you think?
No. Oh, the point slope.
They're going to direct you to
Oh.
that point slope. It's a hoax. It's
There's
a
no
hoax
reason you ever need to use
perpetuated
that.
on the mathematical community.
All these poor students. The point slope form, the 2-point form. All you need is slope intercept form. Did I type it in right?
Yes, 3/4
Okay.
x minus 53/4.
Well, this is one of those assignments that there's not any review problems.
Last
Okay.
one.
It's got to be the hardest one. The way math builds. You learn this little stepping stone, and you got to do it to go on here and stuff. You know how to write those equations if you have the slope and a point.
We know what to do. If they give us the slope and a point, we know use y equals mx plus b, and then ultimately plug in that point. Well, what
Oh,
did they
wait, I
not
thought
give
you'd
us
already written
here?
the problem
No, I
down.
haven't
Oh.
seen it. I was writing the instructions because you emphasized how important those instructions are, Tony.
Have you been writing the instructions all day? Or not?
No.
Oh, okay.
Well, equation of lines.
Oh, you are. Okay,
stuff
good.
like find the equation, just real brief instructions.
Mhm.
Find the equation of a line passing through these 2 points. The line contains those 2 points.
So we know how to do it if we have the slope
And you must know the slope to find an equation
of a line.
of a line. But
What
Yeah.
am I hinting at?
what are we going to have to do?
Find the slope.
We have to find the slope using what?
Let's look through the work and
Let's
see
look
when
through
else
it.
were we given two ordered pairs?
What else? Let's
Where
see.
else today?
The rise over run.
There.
Like
Yeah.
6 and 8, the slope formula. That's when we were finding slopes. That's when they were giving us 2 points. So we're going to have an additional step on number 15. It's like number 14 once we find the slope. So the first thing we have to do is use the slope formula to find the slope of the line. Let's go on. I'm going to treat this as x1, y1, x2, y2. On number 15, they gave us the slope.
14.
On number 14, they gave us the slope. On number 15, they added on an extra step. They didn't give us the slope. Before you can use y equals mx plus b, you have to find m first. And remember that little formula, y2 minus y1 all over x2 minus x1. Now I'll let y'all tell me what I'm going to write. Here,
Let them catch up.
I'm going to let y'all catch up. Well, they catch up. I'm going to take a drink. Okay. What will I put here? 5, that's y2. Here. Okay, I agree. Y1 is 4. Here,
3.
3. That's x2. Here,
1.
it couldn't have turned out to be an integer, could it? What's the slope going to be? 1 over 2. Okay, so it's going to be like number 14. We're going to be stuck with the fraction.
Let's rewrite the problem so it looks like number 14.
Okay, now we know. Okay, so I'm going to rewrite it now. We know the slope. We use the slope formula to find the slope as 1/2.
If we're going to make this problem look like number 14, we don't need two ordered pairs. We need the slope and one ordered pair.
Which ordered pair do you want to use? It makes no difference to me. You'll still get the same answer.
I'm going to say what a teacher years ago
If there were
told me.
negatives, I'd do something that didn't.
Choose the prettier ordered pair.
Choose the prettier ordered pair?
Yeah, that's what, remember what Mrs. Finnegan told me. She told the class to choose the prettier ordered pair, and they all laughed. Okay? And I was like, well, I don't think, if I said that, I don't think everyone would laugh. But choose the
They'd
prettier
roll their
one.
eyes.
Yeah, sigh.
Sigh.
But,
I'd use the one with the smaller numbers.
But
I don't
no
use something with
negatives.
negatives. If there's one that doesn't have any negatives, don't use the negatives. But it doesn't matter. I'm just going to use 1, 4 because that's the thing I wrote down first. So now this is just like number 14. We know y equals mx plus b. So y equals, what am I about to write? Okay, I'll replace that m with the 1/2 x plus b, and my final answer is going to be in this form right here. I'm going to go through, I'm going to find b, and then the final answer will be y equals 1/2 x, and we'll replace that plus b with whatever number we find. We have a fraction. What do you think I'll multiply through by?
2.
2. How many times will I have to multiply by 2?
3.
3 times, because with y equals mx plus b, there's always going to be 3 terms, 1 on the left, 2 on the right. So I'm going to multiply by 2, multiply by 2, multiply by 2. So I have 2y equals, what's going to happen here? The 2's cancel to give me just 1x plus 2b. Now this is the form where we should plug in the xy. This is the form where we'll plug in 1 for x and 4 for y.
See, it's just so much easier plugging it into the thing without fractions.
2, replace the y with 4, equals, what am I writing here?
1.
1, the x value, plus 2b. 2 times 4 is, we have 8 equals 1 plus 2b.
Minus 1.
Okay, so minus 1, that's going to give us
Equals 2b.
7 equals 2b. And we're trying to get b by itself.
B equals 7 over 2.
Oh, okay, so we divided by 2 to get b equals 7 over 2.
That's not the answer. What answer?
The answer is y equals mx plus b.
Y equals.
We know here's 7 halves and here's the slope. So y equals, replace the m with 1 half.
See, look at right there.
1 half, oh, here it is. Y equals mx plus b. The m is 1 half. What am I going to write in place of the plus b? Plus 7 over 2. And there's something called the 2-point form of a line. And, well, wait a minute, I'm going to write it down for them just so they can see the madness.
Write it right
Okay.
here. I mean, but it's
Okay. Y minus y1 equals, well, you need the slope. So they write the formula. Y2 minus y1 all over x2 minus x1 all times x minus x1.
You don't need that.
You don't need that. It's a hoax. I cannot imagine why that was ever created. Same thing's true with the point slope form of a line. Just use slope intercept form.
1/2, right arrow, I can't be in the denominator, x plus
7 over 2.
over 2.
Any questions there? Okay, any questions you want recorded before we stop the video?
Oh, let me see if it's going to work.